Before starting up with the numericals on DC circuit, let us understand what is voltage divider rule and current divider rule. So with that we can proceed with the problem. So let us take voltage divider rule. So voltage divider rule. Okay, so the concept of this voltage divider rule is very useful in analyzing the electrical circuits. So let us say, consider the electric circuit. Let us say I have one circuit here where I have the applied voltage as V and it is connected to two resistances, let me say R1 and R2. So this is R1 and this is R2. So as I said, when the resistance connected in series across the supply, the voltage here across R1, as we have studied in series circuit, this is V1 and this is V2. This is V2. So the current here in the circuit is flowing is, let me say this is I. The current flowing here, let me say this is I. So we can write the current given I is equal to V by the sum of these two resistances, that is R1 plus R2. Because series resistance, what is the equivalent resistance? R1 plus R2. So now if V1 is the voltage across this R1, so if this is V1 is the voltage across R1, then I can write V1 is equal to I into R1, like we analyzed in the series circuit, I into R1. But for this I, let me substitute this value. So substitute I value from the above, we get V by R1 plus R2 into R1. Correct? So V1 is equal to V by R1 plus R2 into R1. So you can just rearrange this. You can take out V outside. So you can say V into R1 divided by R1 plus R2. What you observe here, the voltage across V1. So if you observe, this suffix V1, the numerator resistance is R1. So the voltage when you need to find across V1, so numerator will have corresponding suffix R1 only, okay, 1. So divided by R1 plus R2. So if you want to now find out what is the voltage across this resistance V2 now. So V2 similarly, okay, V2 is equal to, we can substitute I into R2. I into R2. So substitute again for I. So we get V2 is equal to, take out V outside, so R2 divided by R1 plus R2. R1 plus R2. So if you notice here, the suffix is 2 for V2 and the numerator, the resistances, has the suffix R2. So this is how you can memorize the equation, that is whichever suffixes voltages you observe, numerator resistance should have the same suffix there. So this is about the voltage divider. Now coming to current divider rule. Current divider rule. So current divider rule means we have noticed that parallel circuits, the current divides when it reaches the nodes, when the resistances are connected in parallel. So for current divider rule, let us consider the circuit which is in now parallel. So current divides when the resistance are connected in parallel. So let us write a parallel circuit here. So let it this be R1 and this be R2. So let me call this as R1 and this as R2. The current flowing here in this circuit is, let me say this is I. The current flowing through this resistor is I1 and the current flowing in this resistor is I2. So according to this rule, how do you find the current I1 and I2 directly without analyzing and finding? We can generalize the formula here. So let me say V is equal to, we have V is equal to I into R. So if I want the voltage across this is V1 and the voltage across this is V2, let me call this as V1 and I1 and R1, and V2 is equal to I2 into R2, I2 into R2. So we know the voltage applied here, V is equal to the voltage across this is V1 and the voltage across this point is V2. So according to the parallel series I have taught you in the previous video, V is equal to V1 is equal to V2. So when you equate this, okay, so we can equate the equations also here. So I1 R1 is equal to I2 R2. I2 R2. So also we know that I is equal to I1 plus I2. So I can write from this equation, I can write I1 is equal to I2 R2 divided by R1. So I can substitute this equation I1 here. So when I substitute here, this becomes I2 R2 divided by R1 plus I2. If you take common I2 here, I2 as common, I can write this as 1 plus or I2 R2 by R1 sorry, this is not the equation. So this can be resolved into I is equal to, if I take I2 common, this becomes R2 by R1 plus 1. So can solve this now. I2 into, if you take LCM throughout, R2 plus R1 divided by R1. So overall this can be I. So that is now finally we can write this equation as, if I want I2, so transfer this entire term to the left hand side, so I2 will be equal to I into R1 divided by R1 plus R2. So in this formula, you can notice the suffix I2, here the numerator we have the opposite, that is the other resistances. So similarly you can write for I1. I1 is equal to I into R2. So numerator, the suffix changes here to I into R2 instead of 1 here. Then we have the suffix for R is 2 divided by R1 plus R2. So these are the two equations you need to know. Directly we can substitute while analyzing the DC circuit.